Welcome to the final lecture of this section where I'll be talking about the AI standard surface shader. I'm sure you have waited a while to get to this point. This is the most advanced shader Arnold has to offer. It has lots of different physical properties. You can mimic almost 90% of all the materials with just the standard surface shader. So it's a very big topic. I will try to keep everything compact and at a beginner level, but obviously there are some things to cover which are a bit more intermediate and advanced. So feel free to ask any questions, but be sure to understand and check it out. So I'm using the Dragon model, which is a nice model because it has lots of different little features on it. You can get it on the website I posted, 3dscans.com, and you can just choose the Dragon and download that. It's an OBJ format, so you can use it right out of the box. You can actually have a scale there as well, which is very helpful. So this is the model I am using in the scene on the left here. I have the standard shader assigned, so let's hit start and the render just gets going. So this is now the default parameters of the shader. The default is 80% white shader. It has some specularity, and this is most of it. So before we jump into the whole thing, let's just quickly talk about the options it actually has. So on the top, you can actually see it has the diffuse components called base, which is very interesting because this also simulates a metallic shader. So you have your weight for your color, then you have a diffuse roughness slider, and you have a metalness. So this slider changes the whole shader completely into a conductor metal, and if it's off, it's a dielectric, which means it's kind of a non-metal versus metal. Usually you don't blend it. Usually it's supposed to be a Boolean value. It's either 0 or 1. But you can mix it, but it's not recommended to keep a physical property of a shader. Alright, so the next section would be specularity. So you have a weight as well, which is controlling the intensity of the color. Then you have a base color, you have a specular roughness, index of refraction, you have some presets for this. Then you have anisotropy, which is kind of a fake brushed metal effect. You have a rotation of the brush strokes. Then you have transmission, which mimics glass. If you want to create like fiberglass or plastic or like brushed, like sandblasted cups or whatever, you can do it with the transmission. Then you have subsurface scattering, which mimics skin shading or a translucent object like leaves, like wax or milk. You can simulate it with the subsurface slot. A coat is just another specular layer, which is on top of the ones which are listed above. So it goes on top the subsurface, it goes on top the transmission, and on top of the spec. We also have a sheen, which has been added to Arnold 5.2, which is a kind of a neat effect to create cloth or some sheen effects, like instance for skin or for some fruits like peaches. They have like this peach fuzz. You can use sheen to mimic that effect as well. You have emission, which is illumination. So you can actually add a map to the emission slot, or just increase the weight and your object will self-illuminate. Then you have a thin film algorithm in here, which mimics some oily sheen, some oily layer on top of the code, which kind of affects something like oil or like soap bubbles. They have these little thin films on top. Also, certain kind of bugs on their shells, they have these color shifts of green and purple and sometimes blue, and you can mimic that with the thin film. The geometry tab is used to optimize your renders for, let's say you want to have leaves. You can plug in a opacity map to cut them out. You can plug in a bump map for surface normals. You can change the anisotropy tangents with a map as well. And you can enable thin walled, which would mimic something like a soap bubble or like a thin sheet of paper. Matte is just something for compositing. It's nothing really affecting the shader. AOVs as well. Then you can mimic caustics, which is mostly for metallic surfaces. They produce some kind of reflectance light onto the surface, which you would enable here. Internal reflection is used for transmission, which should be on because it's physical accurate. It takes longer to render, but it's physical and it should be on default. Yeah, so this is kind of talking quickly about each parameter, and now we will go into more detail, and we will start obviously with the base. So a typical color is like, I tend to use a weight of 1 and then just control everything with the color. So a default gray shader, like something you would see on the film set, would be on 18% black, right? So this is something which is a typical gray shader, like a shader ball. And then I would typically change the roughness maybe to 1 to mimic a rougher surface. So this would be typical for any kind of dielectric surface. Obviously, if you want to mimic like a hard plastic, you would change it to the diffuse roughness to 0, which is more Lambert. And then you would choose a, let's say, a red plastic, maybe not as bright, but something like this could mimic already a red plastic material with these specular settings. So on default, these two tabs are on and the rest is disabled. So let's say we want to create a red metal though instead. So all you gotta do is keep the color on red and just change the metalness to 1, which will change the shader completely. And you can already see now we have a nice shiny red dragon on the left. So these two things change how everything works inside of the shader. So it's either metal or it's a dielectric. So it's either 0 or 1. The next step would be, which is I guess self-explanatory, is the roughness. You can play up the roughness to create a softer brushed metal effect. You can create really interesting results by plugging in maps in the roughness slot. You can also do some color shifts in here. And so you can also see that if the metalness is on 1, the IOR gets disabled, because it's kind of the same as playing up the IOR pretty high up. So if you have an IOR of maybe 50 or 60, you kind of get the same effect if you would change the color to a red 2. And then we need to play down the roughness again. So I would say it's a similar effect, but it's definitely not the same. So I would always encourage you to go with the system and use the metalness slider, put this guy to 1, and you should have a proper metal shader. The cool thing with, if you have metalness on and you change the color in the specular tab, this would mimic a edge color. So it might be hard to see, but you should actually see some green sheens on the far edges. Like you can see some green reflecting here and maybe something on the belly of the dragon. So this is something how you would do that. So this would be the base reflection color and this would be the edge reflection color. So this kind of already sums up the metalness of things. So let's say we want to create a glass dragon. So this is pretty simple to do. So first of all, we should change the colors to be completely black, because glass doesn't have any diffuse and it is definitely not a metal, and it doesn't have a specular color. So this is very important, and also the roughness should be very low, maybe 0.05 to get really crisp reflections. And the IOR, this would also control the transmission IOR. So let's say we want to create water, or let's just choose glass. So we choose a glass preset, IOR is 1.5. On default, transmission is off. So let's just bring that to 1. And now we get already a translucent dragon. The only thing to consider is on the shape of your object, you would need to change the Arnold options to be opaque off, which means it's a transparent object, which will have interesting shadows, and it works better with some parameters inside of the transmission. Render times do go up though, so that's something to keep in mind. So the specular is preset as it should be, and now you can play around in the transmission settings. So you can now For instance, let's say we want to create a red glass dragon, we would change the color of the glass to be red, and you can see you get a nice translucent effect. If you play around with the depth, you can specify how deep or how thick a glass is. So depending what number you put in there, you get a really solid looking glass or a really translucent looking glass. Think of it as if you go into a bank and there's like they have these big glass doors, or like if you have glass tables and you look from the top, you can actually see through the table. But the more you angle your view and you look through the thicker side of the glass, you can see it gets really dark green or almost black. This is kind of the same effect which we mimic here. So let's just say we have a kind of like a bluish greenish glass. Let's just make it a bit more apparent. If we go a bit more into the blue colors, something like this. Like this is kind of a typical glass, you would think. So let's play with the depth. If I play up the depth to maybe a value of 5, you can see at the base it gets really thick, but then on his horns or the scales, I would say, it gets very transparent. And this is just by changing the depth value. And the higher I go, this is defining the thickness of the glass. So if I go a value of maybe 25, you should see that it gets really see-through at the top, but then the thicker the body gets, it's still very thick and you can see the color of it. So this is what it's mimicking. And the scatter is something also interesting. This introduces some particles, some dirt or dust inside of the glass. So if I play up the scatter, you should see that it gets more milky and as if there's something inside of the glass. And you can also add a color to this. Let's say we want to have some brown dirt or some residue of this. You can easily just do that by bringing in some saturation, changing my hue shift to something more interesting. And now you can already see that we get something here which is more brownish milky. Play up the value and you should get a stronger effect of this. You can see now the body gets really milky and more yellowish now the more I play up the value. And the scatter and anisotropy is just like a kind of a shift towards the inside or the outside of the surface. So if you go to a value towards 1, it will be really transparent on the outside, but really thick when the ray goes inside the object. And if it's a negative value, it's the other way around. Dispersion Abbey is a physical value which actually breaks the wavelength of a ray into its separate components. You would see this in diamonds or sapphires and really strong hard glass objects where the glass goes, where the ray, the photon, goes through the glass and is then being split up. I can try to mimic this if I play up the value maybe to something around maybe 25. At first it looks really weird, but then when it resolves, you can actually see that there's some color tearing going on, and it actually looks a lot more realistic. And you can see what I'm talking about once the image resolves a bit more. Towards the top here, you see these color shifts. Like it's really subtle, but it's there and it looks very cool actually. So let's say I just play up the default colors and I remove the scatter and I remove the depth. Maybe it will be more apparent then. So scatter goes off as well. Alright, so the scatter is off and I played up the dispersion Abbey up to 80, and you can see now on a white glass shader, you can see that there's some color going on. There's green, there's red, there's like lots of colors inside the dragon, and this is how it works. So look at the image now, and if I change the value to 0, you should see a dramatic difference. So now this is a value of 0 and you can see how clear and white the glass looks. And this is definitely not physically at all. The refraction is fine, but it's not how glass would behave. There's nothing like this. So one thing to keep in mind is that the roughness plays up the roughness of the transmission as well. So if I would play up the roughness to 0.2, you should see that my refraction also gets blurred. It's more like a milky glass now. And this is how it works in the real life too. So you have your roughness of your specularity, and then it will also affect the internal roughness of the transmission. So if a roughness of 0.5, you can see now it almost looks solid glass. It's a very cool effect. It takes a while to resolve. And if you want to create an interesting shader, you would just bring in some coating, and then you have like a glossy sculpture, which is actually a rough transmissive glass. Very interesting. It takes a long time to render though. Okay, just disable the code again, and I will also disable this transmission. And also I will go back into the shape and make my object opaque again. And let's head back to the standard surface shader. And the next important thing, or very interesting thing, is subsurface scattering. And as I said before, this is mimicking translucency inside of an object. So on default, an object is either subsurface or it's diffuse. So you should not try to mix those two values together. What I mean by this, have maybe 0.5 weight for subsurface and then the rest is base, which is weird, which you shouldn't do. So let's introduce a value of 1 for subsurface scattering. So this object now is completely translucent. The first thing I want to brush up on is the type. So you have two different types. Diffusion is the original Arnold diffusion mode, and the random walk is pretty new. I think it was introduced in Arnold 5. This is a way more accurate way to represent scattering. So this is ray tracing a lot more accurately than before. So I'm trying to never use the diffusion mode again, just because of its inaccuracy. And you can see that on fine details like skin or noses or mouth areas on the human. So the first thing I want to do is change the mode to random walk. You can see now that there is not a big difference, but we will get there. So scattering is very dependent on scene scale. So depending on the height or the unit of the object, you would need to adjust the scale. So on a normalized value, on a normalized object, which is maybe 1 meter big and a radius of a value of 1, and the scale of a value of 1, the subsurface scattering effect would go 1 unit deep. So let's say I have a subsurface base color of, let's try something organic, like let's say something yellowish like this is my base color. And you can already see now that with a wide radius, you can see that the color is bleeding through this object at a scale of 1 unit. And depending, as I said, on the scale of this, if you would scale it really down, you would see a lot more translucency happening. I can try to show it to you. If I go into the viewport and I actually scale the dragon down, you see the more I scale it down, the brighter it gets. It's because it's scale dependent. So a small dragon with the same shader parameters gets really white because the ray is tracing very deep into the object. But the bigger I scale it, you can see the more solid it gets and the less light goes through the object. And this is how it works in the real world scale as well. So let's just bring it back down to its original size. All right, now you can see once it resolved, you can see now with this scale, the light is penetrating this much. So you can see it's going underneath the gum of the dragon. So the next thing what I would do is adjust the scale until I find it looks correct. So based on the scene units, let's just halve the scale. So it means the ray is only going half the distance as it was before. So now you can see that it's pretty much solid everywhere except on these thin filament areas. Currently we have a white color. So let's say we want to introduce a more bloody color. So let's change the color to be a more darker orange, more reddish color. And let's play up the saturation a bit more. Let's go a bit more red. Based on the color, it also defines the ray distance. So darker values do not go in that deep as lighter values. And also, if you have a value which has a high number in the value itself, this is also a factor which defines how deep the ray penetrates. So a value of 5, the ray would go in 5 times deeper than a value of 1. So that's also something to keep in mind. I tend to keep this value on 1 just to get rid of all the confusion, and then play around with the scale if I don't find it appealing enough. So if I want to see more translucency in the mouth area, I would bring back the scale, maybe 0.8. And now you can see it gets a lot brighter in the mouth area. Another important thing is the anisotropy, which is kind of pushing the edges to be more translucent or less translucent. So if I put a value of maybe 0.8, you can see that the whole thing gets a lot more transparent towards the thinner parts. And a value of negative 0.8 will look a lot more like a solid object. You can see now this looks almost like a diffuse, and it's kind of just shifting a bias towards the back face or the front face of the object. So a value of 0, which is uniform spread in each direction, is more realistic, definitely. So this would kind of mimic a typical scattering shader, and obviously they have presets. So let's say we want to go for, this is what you would get with the default presets of a ketchup material. You also have lots of other parameters shipped with M2A, so I'm not sure on other packages if you get the same parameters there. So this would be a ketchup scattering shader. So let's just disable scattering for now and talk about code. So if I would have a really rough base like this, and I want to clear coat it like a car paint, for instance, or something which is just spray painted with a clear coat layer, you would play up the weight of the coat and you would get a clear coat on top. You can play around with the weight or the roughness. Normally a clear coat is super clean, and you should reduce the roughness a bit. And then you have acrylic mostly for this, which you can just play up with being plastic or glass. They all should be fine in terms of IOR. So this would be a clear coated rough diffuse material. If you would like to mimic some kind of metallic paint, you would just change the base to be metalness to 1. You would play up the base color to be maybe something red again, play around with the roughness, and you get already a clear coated metallic paint or shader, whatever this is. And the last thing is we want to talk about sheen and thin film. So let's say we want to have a peach or some organic looking material. I would have a metalness of 0. Let's say we go for a kind of a peach color, maybe a bit darker and a bit more saturated, maybe a bit more reddish. I don't know, something like this, whatever fruit this is. And let's just introduce something called sheen. Let's bring up the weight, and you can see now only on the edges we get this white effect. It looks like kind of dusty, like flour on top of this. And you can also colorize this to get some kind of cloth effect or satin. So if I have a red sheen or even like a more pinkish sheen, this looks like now like a pearlescent paint or something like that. The roughness is kind of shifting it towards the inside or the outside. So the rougher you make it, the more it goes around the surfaces. And this would mimic like a cloth shader. If you would bring up some specularity to this, maybe something like this, this would look like a really shiny cloth or something like that. But for an organic thing, this should be left to white. And you can see now what this looks like with a sheen applied. The last thing is the thin film. So if I would play this up maybe to a value of 500, and I play up my IOR here, I think this is what we need to do. You can now see that we get some color shifting on the edges here. And I think if I play down, reduce my roughness a bit more, you can see that we introduce some green, like a greasy, oily layer on top of this. And this is actually in, I think, nanomillimeters or something really small. And it's the range of the thickness of the oil layer. So you can see by playing around with these values, you get different results. You can see now it's almost purple. And what you can do, which is interesting, you can plug in a noise pattern here to modulate some flow noises or some flowy texture on top. So to get the best looking results, you would plug in a noise map to modulate surface thickness to get some modulation in the iridescence effect. So this should cover most of the basics of this shader. I know it has been a very long lecture, but it covered quite a bit, and I was talking about most of the components of the shader. And by now you should be able to really make use of the information I gave to you to create your own good looking shaders and physically correct ones. And if you have any questions, please follow up with me, ask some questions, and I'll be happy to answer them if you have any struggles with the shader. I know it's a complex one. That's why I want to really be sure that you fully understand what's going on here. And just to quickly show you the emission, it's just as easy as introducing emission. And you should see, if you have a base texture, you should see that it's actually emitting light. You can see that my Macbeth charts get really illuminated. My Lambert shader gets illuminated. So this is what emission does. So yeah, thank you for staying on topic and watching the whole lecture to the end. I know it was a tough one. Watch it again if it's something is not clear. And as I just said before, ask any questions. So thank you guys. I see you in the next section.